5G offers a whole new suite of applications. 22.8 or 23 million new jobs will be created in the 5G telecommunications technology. Plus, it's going to add around 1.7 trillion US dollars to the US economy. We expect people from across the spectrum who have expertise in more than one area. Professionals who are either members of technical staff, who are senior engineers, who are senior technical architects and solution architects, senior algorithms engineers, senior scientists. All of them would be able to learn and avail this course towards getting into more principal and more higher level positions. I'm Dr. Rajaraja Sivaraj. I'm a director for standards and architecture at Mavenir. I've been with the company since August 2020. Prior to joining Mavenir, I was a senior inventive scientist with AT&T Labs Research. My area of expertise lies in 4G and 5G, cellular RAN systems design, and cross-layer networking. I've also had work experiences with Microsoft Research, Intel Labs, Broadcom, NEC Labs America, and Princeton, New Jersey. Prior to my industry experience, I finished my PhD in computer science from the University of California at Davis in December 2016. I'm currently based out of Plano in Texas. So this course is a 24-week course that focuses on three key aspects. Number one, 5G communication systems, where we go into the details of the system's design and understand the standards as well as the whys of the standards. So this helps an individual to gain a lot of expertise about the communication protocols that we use in 4G and 5G telecommunication networks, focusing on the radio access network, the core network, as well as applications. So as we move towards 5G, we have a whole new suite of applications, such as augmented reality, virtual reality, 360-degree video streaming from drones, driverless cars, etc. So how do we provision such applications over telecommunications network? This forms the first stream of the course. Then we go into machine learning and artificial intelligence, more from the concept of applying scalable and practical machine learning in the telecommunications domain. We get into the basics as well as the advanced concepts of machine learning, but given that this is not a standalone machine learning course, we cover the details of how we apply the skills that we gain from machine learning in telecommunication systems design. And the third part of this course is how do we build telecommunication networks from a cloud native and virtualized standpoint. We discussed the concepts of network function virtualization, software-defined networking, that would be used for building mobile and telecommunications network with a cloud-based design principle. So these form the three streams of the course that we are planning for, for the 24-week program being offered through Skill-Lync. .5G offers a whole new suite of applications, such as augmented reality, virtual reality, 360-degree video streaming from drones, 4K and 8K high-definition video streaming, driverless cars, remote telesurgery, remote factory automation. So with these whole new suite of applications, with this myriad invention and with this whole new suite of applications, it is very much required to understand the details of the protocol design and the details of optimizations that would be useful towards offering these applications in an optimized way through the mobile network operator. So it is extremely important to know the fundamentals as well as the advanced concepts of communication design that would basically help the operators as well as the vendors towards provisioning these new suite of applications. Now, also to have in mind that there are a bunch of widely referred stats which say that 22.8 or 23 million new jobs will be created in the 5G telecommunications technology, from now on till 2035. These are basically estimates from RCR Wireless and a bunch of other sources which gather stats about how much of market that this industry is expected to create. Plus, it's going to add around 1.7 trillion US dollars to the US economy. Plus, it's basically going to bring in about 23 million jobs, as I said, with around 10% of the jobs or more just focused in North America. Around 50% to 70% of the jobs in the Asian market, typically China, India, Korea, etc. And about 25% of the jobs in both North America as well as in Europe, with 10% of the jobs exclusively in the US. And these whole new suite of applications requires a person to be at the intersection of expertise in both telecommunications as well as machine learning. Both the domain expertise as well as expertise in analytics and optimization and computer science optimization is required so as to be able to come up with innovative algorithms that help provision these applications and meet the expectations of service quality and experience requirements of the customer. Up until 4G onwards, we basically required more unidimensional skills. For example, we expected an employee to have skills just in the telecommunications side. So we required systems engineers who had adequate expertise on the telecommunications, on systems design, on the protocol stack. And then we basically didn't require these people to have skills in other domains such as machine learning, in cloud, in microservices, etc. But 5G is basically an interesting, it's basically an interesting game shift because you're expecting people to have expertise not just in communication design, not just in wireless communications, but also in these areas of computer science optimization, algorithms, analytics, machine learning, data science and data engineering, as well as cloud native microservices design expertise. So we expect people from across the spectrum who have expertise in more than one area, communications, computer science, algorithms, to come together because that is what is required towards provisioning these myriad applications that we reviewed. With just unidimensional skills and without expertise on other areas like machine learning, we wouldn't be able to come up with solutions that cater to the needs of these applications. For example, 5G focuses on three key areas. Number one is bandwidth intensive applications that require extremely high speed. Number two, ultra low latency, which typically expects round trip times of less than 10 milliseconds, less than 5 milliseconds, and sometimes units of milliseconds. And then extremely high reliability. That is even a data loss in the order of 10 to the negative 5 is not tolerated. So some of these applications require, reliability in the order of 1 minus 10 to the negative 5 to 1 minus 10 to the negative 7. So this requires extremely high reliability. These require extremely high reliability to be met. So in order to cater to these requirements, it is expected that an employee has expertise in multiple areas. Communication design, how he can use computer science algorithms towards solving these communication problems, and how can he scale up his design, how can he use more cloud native, innovative microservices and services-based architecture, leveraging the power of cloud computing, analytics, towards designing systems that offer these applications through 5G technology. And the skill gap that we basically have is that we don't really find many people who are at the intersection of these multiple skills. So that is one of the reasons why we need to equip a person who's having probably 5 to 10 years experience just in the wireless communication and wireless protocols, we need him to be equipped with computer science optimization techniques, with machine learning, with data analytics, and also we require people, who are systems engineer in cellular networks to also be equipped with cloud native and microservices design, cloud native software, cloud computing, and a bunch of cloud orchestration tools. So that's one of the reasons that we've come up with this course that helps meet these skill gaps and gives a more interdisciplinary dimension to this course that touches upon these multiple aspects of technology. Engineers who are enrolling in this course would basically gain more hands-on experience with the technologies that we're covering, predominantly 5G systems design, AI, machine learning and analytics, as well as cloud-native microservices systems. So in 5G, the engineers would have an opportunity to learn or to make use of the widely used open source simulator for 5G called NS3. Engineers would be able to do projects in NS3 where they would essentially simulate the protocols and the concepts that we are covering in that stream. This will basically give them a lot of hands-on experience in understanding the algorithms that are used across the multiple layers of the cellular RAN protocol stack, as well as in the core network. So, of course, it's a simulation, but the advantage with simulation is that they would be able to simulate a network at scale, and they would be able to, evaluate a large-scale simulation of the network and be able to understand how the protocol stack is operating, at scale with tens and hundreds of users, with tens of nodes, with tens of cells. So this will give them a more ground truth understanding of how the layers of the protocol stack are designed. And then there is also an opportunity for the engineers to make use of this widely used packet capture tool called Mobile Insight. It's basically a sniffer tool that can capture, packets on the mobile devices. Now, it's an open source tool, which means it can, it can work not just on iOS devices, but also on Android mobile devices, as well as other mobile devices as well. So what Mobile Insight does is that it basically captures, RAN protocol data units, which are exchanged between the mobile device and the network. So this will basically give them logs across all of the layers of the protocol stack, and this can use real mobile devices that are connected to real networks, and they would be able to, extract or log, millions of records of data, transmitted over a real network, parse the data extensively, and try to evaluate the performance of the systems in real world. So that's another tool that is offered as part of the course in the 5G stream. Then as we move on to machine learning and artificial intelligence, we'll have an opportunity to train the engineers in a whole bunch of machine learning tools and Python libraries, such as TensorFlow, Keras, Skill-Lync, and this would basically help them understand how to implement machine learning algorithms, supervised machine learning algorithms, unsupervised machine learning algorithms, semi-supervised, reinforcement learning algorithms, offline, online, etc. And then as we basically move on to the third stream, which is cloud-native microservices-based design, the engineers will have an opportunity to learn more cloud-native tools, AWS instances, pods, Kubernetes, and how can cloud-native microservices be deployed, and how can cloud-native microservices that make use of the analytics and machine learning algorithms also be deployed, so that you can basically have a microservices for the network simulator as well as microservices for the analytics and machine learning algorithms, and basically see how data can be sent from the simulator, and how the machine learning microservices can predict the performance metrics, can predict the performance indicators, and then can come up with optimization designs which can be communicated back to the simulator, and then the simulator can implement the recommended actions from the machine learning engine, and the simulator can reflect those actions inside its modules, and that could be used for evaluating the performance of these algorithms on simulated networks. So that's the hands-on experience that engineers are expected to gain out of this course. Apart from the traditional players in telecom that we've been seeing for years, now telecom industry is also home to more innovative and newer players in the ecosystem, such as Facebook connectivity, Microsoft, Google, VMware. All these were big names in the technology industry. Now they are also names in the telecommunications industry. This is because, as we previously reviewed, with 5G onwards, it's going to be a blend of communications as well as technology. It's a blend of telecommunications and technology. It's more interdisciplinary in that sense. So because of the focus on cloud-native design for 5G systems, we basically have a lot of tech companies that are big names in the cloud industry enter the space. Because, for example, if you look at players like Google or Facebook or Microsoft or VMware, who've been big names in the cloud industry, the reason why they are venturing into the telecom space is to offer more cloud-native design solutions for the cellular RAN, as well as to the core network, as well as to applications. And if you look at basically people like Google or Facebook, who've also demonstrated skills in the machine learning space, now, moving forward, telecommunication problems cannot just be solved through basic heuristics, cannot be solved through basic optimization algorithms. We need to leverage a lot of data. There is a paradigm shift in the way how these optimization solutions are being offered. Gone are the days where we just use algorithms and heuristics towards solving these problems. Now, moving forward, we will have to leverage data-driven analytics. We'll have to harness advanced concepts in machine learning that can, capture the complex interdependencies of mobile communication protocols, and basically offer more optimized design solutions that would help in meeting these extremely stringent demands, such as 100 Mbps bitrate, which is expected for mobile broadband traffic moving forwards in 5G, with 1 millisecond to 5 milliseconds latency, and with the stringent reliability values of 1 minus 10 to the negative 5 that we reviewed previously. So when we'll have to come up with solutions for these applications, we require solutions that are not just based on traditional heuristics or algorithms, but leverage the power of data and provide more data-driven, powerful machine learning-based solutions. And that's why you see players from the cloud industry, players from artificial intelligence and machine learning space also enter the telecommunications market. This is in addition to the classical telecommunication players such as Nokia, Ericsson, Huawei, Samsung, etc. We also have a whole new bunch of telecommunication companies who've entered the business, such as Mavenir, Altiostar, Radisys, etc. And in the US market, you also see new operators who've entered the space. So in addition to AT&T, Verizon, and T-Mobile, you also have Dish, which is basically a nationwide operator who's offering cloud-native solutions using Open RAN technology. And if you move to Europe, you basically have Orange, Dutch Telecom, Telecom Italia, Telefonica, etc. And then when you enter the Indian market, you have Jio, Airtel, especially Jio, which is providing some extremely lucrative market for its customers. And when you move to the Asian market, like China, Korea, etc., you have CMCC, China Mobile, you have SK Telecom, you have Rakuten. So a whole new bunch of operators, vendors, as well as technology people are entering the space because of the opportunities that we have in the space. As the industry is experiencing a paradigm shift, now we expect people to have good expertise with newer technologies in telecommunications, such as one such technology is Open RAN. Now the dimension that Open RAN is bringing to the picture is that gone are the days where we used to rely on proprietary solutions that were offered by vendors. The industry is looking at more openness moving forward. Open RAN is a technology that basically allows the vendors to open up their radio access network, to open up their proprietary solutions. So once they are opening up their proprietary solutions, it basically means that some key performance data and some key protocol data can be exposed from the vendor hardware, and can be exposed to a cloud platform, and we can basically have a number of third-party solutions running in the cloud, such as solutions from the operators themselves, such as solutions from other third parties that can make use of the data that they get from the vendor proprietary hardware and use a lot of data-driven machine learning algorithms, come up with a lot of data-driven analytic solutions, and offer optimization solutions that can be sent back to the radio access network, so that the radio access network would implement the solutions that are coming from the cloud as recommendations, which is expected to boost performance. So this is a whole new technology. This is a very new game changer in the space, because previously it was even difficult to get an operator solution into the network because the network was closed. The network was based on vendor proprietary solutions. Vendor wouldn't really open up his network for optimization by even operator solutions, even though the operator owns the network. The solutions are provided by the vendor, so it was difficult to even get the operator to have his solutions ported into his network. So now with more openness, with more tools for handling data, tools for mining data, machine learning tools, as well as with virtualization and cloud platforms, we expect the data to be exposed from vendor proprietary hardware to cloud native microservices, and we can basically have our algorithms and machine learning solutions implemented in the cloud, which can send back actions that can be implemented or that can be reflected in vendor hardware. This is expected to boost performance. Now, we really expect employees to gain skills in such newer technologies, because they need to be equipped with these newer technologies in order to sustain in the market and outperform other rivals in the space. So Open RAN is a new technology. And similarly, as we reviewed previously, 5G by itself is a newer technology. Beyond 5G systems, like how is 6G going to evolve, and what are advancements in machine learning? I mean, even machine learning has a bunch of newer technologies day by day. Reinforcement learning, Bayesian optimization. These are all newer techniques in machine learning. And then when you move to the cloud space, you again have newer technologies like Kubernetes, Docker containers, and a lot of techniques in the space which are expected to be widely adopted in the industry. So it is expected for an engineer to have a good depth of experience in these technologies, so as to really sustain in the market, and also so as to basically scale up in his career ladder. Engineers who would benefit from the course are manifold. Engineers who are relatively new hires in this field, along with people who are experienced professionals. So let's start with experienced professionals. So professionals who are either members of technical staff, who are senior engineers, who are senior technical architects and solution architects, senior algorithms engineers, senior scientists. All of them would be able to learn and avail this course towards getting into more principal and more higher level positions. So these are, the target. These are the target experienced professionals who can take up this course. Now, as far as entry-level professionals, they can take up the course which focuses on the newer technologies that we are offering through this course, such as 5G, artificial intelligence, cloud, and this will basically help them upskill. This will basically help them, boost their skill set and expertise, so as to sustain in this market and so as to sustain in, their workforce. So as I was saying previously, this requires a paradigm shift in the systems that we are offering as well as in the workforce. So even entry-level professionals who need to gain skills in 5G, machine learning, and cloud-native design, they can take up this course so that they would be able to learn the skills and bridge the skill gap early in their career, as opposed to waiting for long before they would bridge the skill gap. So bridging the skill gap early in the career would help them grow up in their career ladder quite fast. And then also masters and PhD students, because these days when we're looking at research publications, which is typically expected from PhD students, there is a lot of emphasis on systems papers, on systems research. When they're expected to publish their research in top-tier computer science conferences and journals, or mobile networking conferences and journals, these conferences and journals give a lot of emphasis to systems research. So here we are not just looking at theoretical concepts, we are not just looking at things at a very high level. Usually when people take up courses in academia, they discuss the fundamentals, and then when they move to advanced concepts, they basically cover things at a more high level. They don't go into the details of systems design, because that's not typically expected in academia. Academia focuses on concepts. They basically tend to ask questions as to what is required, how this is done, how is a solution designed, etc. But they don't go into the details of systems design. So in this course, we bridge that gap by going into the details of systems design, so that any master's and PhD student who is interested to take up a career in telecommunications, or who's interested to conduct wireless and cellular mobile networks research, will be knowing about the systems engineering details and the systems design details. Now, this is really expected when he is publishing papers that focuses on systems research in 5G and beyond 5G. And then a PhD student who is spending his 5 to 6 years in academia would basically want to get started with a very high-paying job with a more senior level position. So for him to start in the industry at a more senior level position, it is expected that he acquires these skills that we're offering through this program. And then that's the same thing for master's students as well, because master's students typically who are not going to be doing a longer term research, they wanted to basically do a program for 2 years and then do a dissertation within those 2 years. But within those 2 years, they probably would also have to equip themselves with understanding the systems concepts and systems engineering concepts. So that's why we offered this course, and the target audience is also master's students for this course, so that upon taking up this course, they can basically learn the skills that would otherwise require them at least 2 to 3 years in the industry to gain these skills. So whatever they would have gained in 3 years in the industry, this course will basically enable them gain these skills within about 6 months. So masters and PhD students are also welcome to taking up this course. And also bachelors who are in their senior years, though this course is a core, this is a very core course. It goes into the details of 5G and cloud and machine learning, and this is a pretty profound course for bachelors. But nevertheless, seniors and students who are pursuing their fourth year in their bachelor's program, they would also be able to take up this course so that it would help them in gaining the required skills that is expected out of them when they enroll for a master's program or a PhD program, or when they enter into a core industry, or when they're looking for placements in core companies. So these are the skills that enrolled students would learn, and this is basically how even the professional engineers would be benefiting from this course, and they can aim for more principal and lead positions from their senior positions when they're enrolling in this course. I'm talking about the professional engineers. Basically, as we reviewed previously, the course will have 3 streams. As I said, the first stream is 5G, so we'll basically spend at least about 6 to 12 weeks reviewing 5G concepts, 5G protocol stack layers, 5G analytics, and also 4G, by the way, because 4G is still in deployment and it's going to be there for the next at least 7 to 10 years. LTE is here to stay for the foreseeable future. So 4G, 5G, as well as beyond 5G concepts. So that is basically going to take about 6 to 12 weeks, and then we will have another 6 to 12 weeks that's focused purely on analytics and machine learning, and then the final few weeks will basically focus on cloud concepts. And then the students are expected to do a project, or the enrolled engineers are expected to do a project in each stream that we are offering. For example, the first stream, the enrolled engineers and students would do a project involving the network simulator NS3, as well as mobile insight packet capture tool. And then when we go into the analytics and machine learning stream, the enrolled engineers would basically have to do projects using Keras, TensorFlow, Skill-Lync, Python libraries, PyTorch, etc. And then when they basically move towards the third stream, which is cloud native microservices design, they'll be able to play around with more virtualized software, with more cloud platforms, with orchestration tools, and all these will basically culminate in projects where they would be able to apply skills at the intersection of 5G communications, machine learning, as well as cloud. So this is how we are planning to structure the course, and basically whatever skills that would have resulted, whatever skills the engineer would learn in the 6 months course is something that he would have otherwise required or taken 3 to 4 years to learn all the broad set of skills that we are offering through this course. So that's how we are structuring this course into 3 streams, and then there's a course project in each stream, and then there is a fluid transition of flow across these 3 streams. Now these 3 are not independent streams; they are well connected to each other, because we are going to review these 3 streams with 5G and communication design as the connecting principle. So even as we go into the concepts of machine learning as well as cloud, it will all be covered from a 5G and from a cellular mobile communications perspective. So it's not like we are going to learn 3 different streams in an independent fashion. These are all going to be completely connected, and the transition is going to be smooth across these 3 streams. An engineer who is gaining these skills can very reasonably expect, can very fairly expect a boost in his pay scale at least by $30,000 to $50,000. Now that's a very conservative estimate, because all the interviews, and not just the interviews, and also the job opportunities and the job responsibilities that they will have to take up, even when they go to more senior level positions, are going to be centered on the basics that we are handling in this course, are going to be centered on the concepts that we are handling in this course. So the target audience, as I said, are engineers as well as master's PhD students. Now, upon taking up this course, certainly an engineer would raise to principal level. So the expected promotion or the expected career position that engineers would be availing as a result of taking up this course would be something like principal member of technical staff, principal scientist, principal technical architect, principal engineer, lead operations engineer, etc. So once they take up this course, certainly there would be an elevation or boost in their career that would result them in acquiring more principal positions and lead positions in their organization, as opposed to staying at a more junior or at a relatively senior level. They would advance to more principal level in their job opportunities, which would definitely result in a pay scale increase by a minimum of $30,000 to an average of around $50,000. The tangible resume-worthy benefits that one can expect out of this course is right up his skill set. He could very confidently cover, all of the key concepts in 5G telecommunications. Right, 5G telecommunications by itself has a number of concepts. Like for example, in the RAN cellular radio access network, we have a lot of layers such as RRC, SDAP, PDCP, RLC, MAC, physical layer. Now, someone who is a professional in the space and who is experienced, he would probably be experienced in 2 out of these 5-6 layers that we've talked about. It is difficult for someone to gain ground on all of these layers, even if he is 10 to 15 or 20 years experience in the telecommunications field. It is very difficult for him to gain expertise across all these layers. Now, at least a fundamental understanding of all these layers, at the bare minimum, is something which an engineer can gain if he enrolls in this course. That itself is resume worthy. Now, when you move to the core network, you have AMF, SMF, UPF, UDM. You also have a bunch of network functions in the core network. Slicing. Slicing is a new concept in 5G. Like, how can you offer end-to-end quality of service and experience through the slices that are basically being provisioned over a 5G network? That's a new concept in itself. So an engineer would be able to learn the ground truth of how slicing operates, of how these functions work. So a very deep dive into the core network is another thing that we are covering in this course. So this is also resume worthy. And then applications. For example, many of us have used AR, VR, video, etc. But how do these applications work? In practice, how are these applications streamed through a mobile network? How do these applications perform in a mobile network? How does the protocol operate? So these are skills that an engineer can gain in this course. Like for example, what is the difference between 360-degree video streaming and a normal video streaming? Because it is expected for a communications engineer to know that, so that he would be able to come up with algorithms that would optimize these video streaming and AR, VR streaming over a mobile network. And then again, so these, complete coverage of the 5G communication network is by itself a resume-worthy skill that one can have in his resume. And then the tools in machine learning that we are reviewing, and we are not just enabling an engineer to just use these tools. We are basically getting into the details of the concepts. For example, how can he distinguish between a reinforcement learning and a regression model? For example, how would he distinguish in terms of applicability? Where can he apply reinforcement learning? Where he can apply regression models? Where he can apply semi-supervised learning? Where he can apply supervised learning? Where he can apply Bayesian optimization? Now, these are the skills that he can acquire in this course. So it's not just trying to write a Python script that would basically do prediction, but trying to get a ground truth understanding so that he would know where to apply these skills, where to apply these tools. And again, cloud native design is something where he would be able to gain good expertise on the software implementation. Like, how can he implement the system now? Okay, he's learned the system well enough. Now, how can he implement the system? How can he use, microservices design? How can he implement a scalable system or a system at scale? So these are all resume-worthy skills. And in addition, the tools that we are using, right? NS3, Mobile Insight for the RAN side or for the network side, and all the Python libraries that we're using for the machine learning side, and also the exposure to cloud native tools that we are covering in the cloud stream. So these are the resume-worthy skills that an engineer could have in his resume, in his CV. the people would miss out on the following. If they are not able to gain skills that we're offering through the course, people would lose out on the following. Number one, lack of understanding of how a 5G or a 4G system works. Now, 5G or 4G system or communication system, for example, it is not a very simple or straightforward design. There are a lot of inherent protocols. There are a lot of intricacies that are handled in the way we design a system because of the number of concepts that we'll have to support, the number of features we'll have to support in a cellular mobile telecommunication network. So, a lack of ground truth understanding of how a 4G or a 5G or a beyond 5G cellular system would work. Second, lack of exposure to analytics and machine learning techniques in the domain of telecommunications. Like, how can people apply machine learning techniques to solve telecommunication problems? That is something that people would lose out on. Because in this stream, we are not offering a standalone machine learning course, right? We are offering a course that would enable people leverage machine learning skills on solving practical telecommunication problems. So that is something that they will lose out on. Lack of exposure to cloud native technologies and cloud native design principles, because gone are the days where people used to rely on monolithic technologies. Now moving forward, even communication systems like 5G are going to leverage cloud native design principles, cloud deployments, harnessing the power of cloud computing, cloud storage, cloud native analytics. So these are the skills that people would lose out on as a result of not learning the skills that we're offering through the course, because these form the fundamental principles of how we are going to design telecommunication systems moving forward from 5G onwards. Industry is basically expecting students who have acquired systems research and systems understanding skills, because when you're looking at papers which are getting published these days in top tier mobile networking conferences and computer science journals, right, it is not just academia which is publishing papers. We are also seeing a bunch of papers being published from the industry. So not just academic students are publishing papers as far as telecommunications is concerned, as far as mobile networking is concerned. We also have a lot of industrial research lab and industrial R&D groups which are publishing their research papers. So PhD students who are learning this course would acquire the right systems design skills. Plus, we are also targeting R&D aspects in this course. For example, how can algorithms be designed? How can machine learning algorithms, machine learning tools be used? How can we come up with some of the latest sophistications in machine learning tools and latest advancements in machine learning algorithms and use that towards solving communication problems? Now, there is an R&D angle to each of this. Plus, when we are going to the details of the 5G stream, we would also go into the details of the trade-offs in system design. For example, what are the problems in designing an algorithm, or what are the problems in designing a certain functionality in the layer of a protocol stack? Now, we understand the problem thoroughly as we go into the details of the courses that we are offering as part of the first stream, which is going to be 5G telecommunications design. A student would get a good understanding of how the layers of the protocol stack work, what are the open problems that we face in these systems design aspects across the layers of the protocol stack, what are the inherent trade-offs that must be addressed while designing an optimal system. So that is this is the exposure that a PhD student or a master's student would gain from the first stream. The second stream, as we discuss machine learning algorithms, right, he would gain good insights on how to apply machine learning algorithms towards solving these problems, and also learn newer concepts in machine learning algorithms, some of the latest advancements in reinforcement learning, for example, in deep Q neural network, for example. So these are the skills which the PhD student would learn, because now these skills that he's learning from the second stream will be applicable towards solving the problems that he has learned in the first stream. solving the problems that he's learned in the first stream that covers cellular network systems design. And then when the student wants to implement a prototype of the system, the skills that he would learn from the third stream would help him understand cloud native principles, analytics, that would help him implement a prototype of the system that he is designing, which would essentially handle these problems that we've reviewed in the first stream, and would essentially leverage the solutions that we've learned that we would be learning in the second stream. The student can also target publications in top tier networking conferences such as ACM, SIGCOM, MobiCom, MobiSys, MobiHawk, IEEE Infocom, IEEE ICNP, journals like IEEE Transactions on Communications, IEEE Transactions on Networking, or ACM IEEE TON, IEEE JSAC. Now, these are all conferences and journals where a student can publish his papers, from the skills that he's acquired through this course and from the open problems that he's exposed to. When we are reviewing the details of 5G design and 5G systems that we are covering in this course. Definitely a student in his bachelor's who's in his senior year or fourth year, as we call in other countries, upon learning this course, it would really help him gain solid insights and solid skill set that would definitely be influential towards his admission in master's and PhD programs in American and European universities and also elsewhere. Because one of the reasons that professors are looking at these days, like top research professors or top research scientists who have their research labs through which they're offering PhDs or through which they are publishing papers or expecting from students, is that they expect the students to have a very good understanding of how a system works, a very good understanding of how the trade-offs in a system are, and a very good understanding of how they can apply algorithmic design and optimization solutions and machine learning solutions towards these problems. Because once they gain admission to master's and PhD programs, a lot of their time would basically be spent on exploring a number of open problems that are present in the system. So when they get to explore the open problems that are prevalent in the systems, they need to understand the systems very well. They basically need to have a very good understanding of how the systems work, how there are interdependencies across multiple layers in a system. So without getting that ground truth understanding, they would not be successful in unraveling open issues that are prevalent in the systems and coming up with state-of-the-art solutions towards solving these problems. So that's one of the reasons why the fundamentals that this course is offering, even though this course could be slightly heavy for senior students or for students in their bachelor's or students in their fourth years, I still feel that the fundamentals and the skills that they would be gaining from this course would be extremely useful and vital for them to gain admission in their master's PhD programs and then pursue their ambitions and pursue their goals in optimizing these systems, identify the open issues that would be prevalent in these systems, because it is required to optimize the systems design aspects. It is important to bridge the gaps that we have in these systems. It is important to address the issues, the open issues that we have in these systems as we move forward, because the moment they step into their PhDs and the moment and by the time they finish their PhDs, we would have probably gotten evolved to 6G. Now we are in 5G, maybe within 5 years from now, we would have gotten advanced to 6G. So now all those issues that are prevalent in 5G need to be really fixed in 6G as we move forward. So this will help them gain a lot of ground in understanding 5G and understanding machine learning, and identify the issues, moving forward, because once they join in their PhD program, they would be able to unravel, the issues that are prevalent in these systems and come up with state-of-the-art design solutions that are worthy of publications, that are worthy of getting patented, and improve the performance of the system and come up with very innovative, solutions in the space.